Welcome to Back to Basics. Today, we're going to talk about database replication. In the simplest use case, this can be between two AWS accounts in the same organization. A common requirement is to copy data between two different environments. For example, between production and UAT, to support testing, and to share data between two separate teams that manage their own databases. Another use case is to support hybrid architectures, where an application and the corresponding database is moved to AWS, and an on-premise database needs to be kept in sync to support on-premise applications that haven't migrated yet. Today, more frequently, data is also stored in third-party applications or SaaS solutions that are hosted on AWS. In this situation, we still need to have the capability to combine all our data for various analytics use cases. So as you can imagine now, it becomes more challenging to implement a secure and scalable pattern for all of these use cases. In this episode, we are going to walk you through the steps for setting up a secure and scalable pattern for database replication between two AWS accounts. In our example, we have a consumer web application running in a private VPC across two AZs. This application wants to run advanced analytics on all of their portfolio holdings. In order to do this, this application needs to have access to the portfolio data that is available in a SaaS application that is used by their business to manage all portfolio holdings. The SaaS provider runs and maintains an isolated relational SQL Server database for each customer. Things you want to consider for this architecture are the following. First, from a security perspective, no communication should occur over the internet, and that we can lock down ingress, egress traffic to dedicated private IPs from and to the third party. Second, from a flexibility perspective, that we might want to use a different database engine like Amazon Aurora on the consumer side to reduce costs down the road. Third, from a scalability perspective, that we might require dozens or hundreds of similar network connections with other AWS accounts in the future. These requirements lead us to use Private Link for network connectivity, as VPC peering won't be scalable, and to use Database Migration Service, DMS, for database replication, as it provides cross-engine replications. In our example, we want to replicate the database in the SaaS application VPC to a SQL Server instance in the customer VPC. VPC endpoints make it easy to create a private connection between two VPCs of different AWS accounts in the same region. Traffic between both VPCs don't leave the Amazon network and don't require public IP addresses. For cross-regional use cases, we can extend this pattern via VPC peering to other VPCs in another region. To expose this database to other consumers, we need to front-end the database with a network load balancer. In the network load balancer, we register the private IP and the port of the database instances as a target group, and adjust the security groups of the database to only allow traffic from a network load balancer. Finally, we can set up the VPC endpoint services by creating a service configuration and associate it with the network load balancer. For security reasons, we require manual approval for all connections. The third party can now request an interface endpoint for the previously configured AWS Private Link service in their VPC. The interface endpoint can span one or two availability zones, is redundant, and scales horizontally. After the service provider approves the request, the endpoint is available as an ENI in the third-party VPC. As previously mentioned, we use AWS DMS, Database Migration Service, for the database replication. And as a first step, we set up a DMS instance in the third-party VPC. The DMS instance requires connectivity to the source and the target database. We configure the security group of the source database to allow access from the DMS instance. Access to the interface endpoints can be controlled by endpoint policies. So by default, endpoint policies allow full access to the service. So in this case, we need to tighten up the security and define an endpoint policy that allows only access from the DMS instance. So now we have everything in place from a security and networking perspective to continue with the setup of the database replication. As a best practice, you wouldn't put inline any firewall or network inspection device between the private link endpoint and the database. In our example, we want to configure the SQL Server instance in the third-party VPC as a source database in DMS. For the target database, we configure in DMS the private IP of the VPC interface endpoint and the SQL port of the database in the customer VPC. Alternatively, you can also use private DNS names for VPC interface endpoints. We have chosen to set up DMS in the SaaS provider or third-party VPC, as this gives control of future DMS changes, for example, frequency of replication tasks, to the third party. Depending on the needs of your setup, this pattern can be also set up the other way around. DMS can continuously replicate data with high availability between two data stores. Tasks defined in DMS can perform a full load, cache changes, or ongoing replication between two data stores. I've used this pattern more than once, especially for security conscious organizations. Now you can use it too. Check out the links below for more details. See you the next time.